Voilà, bonjour. Merci d'être aussi nombreuses et aussi nombreux pour le séminaire de Jim Skea, dont je vais faire la présentation un petit peu plus tard. À l'occasion de la visite du professeur Jim Skea, qui est donc président du GIEC et qui va nous parler de cette noble institution. Je voudrais d'abord donner la parole à Nathalie Carrasco, qui est présidente de l'ENS Paris-Saclay, et puis ensuite à Sophie Zopa, qui représentera l'Université Paris-Saclay.
Ah non, ça marche pas. Ouais, très bien. Ça, je te laisse. Donc, bonjour à toutes, bonjour à tous. Je vais basculer en anglais puisque je veux m'adresser à Jim Skea et lui adresser quelques mots de bienvenue, mais évidemment, vous allez tout comprendre. So, good morning, everyone, dear colleagues, dear students, dear Professor Skea, Professor or Sir or President. You have so many titles, but to make it short, dear Jim. It's a pleasure and a great honor to welcome you here at ENS Paris-Saclay. I will take just a few minutes to present where you are today. In a few words, ENS Paris-Saclay is a highly selective graduate school for research and education. We train about 1,500 students to practice research in a large spectrum of disciplines. They follow reinforced pathways in basic sciences, in humanities, and in engineering sciences. So we develop, it's a strong point here, to develop interdisciplinary approaches. If you have time to visit during your day, you will see that laboratories and academic spaces are physically intertwined and close together within a single building. By promoting interdisciplinarity, we aim at dealing with complex issues in order to face the social challenges that we are reminded of every day. And in an increasingly difficult international context, as you know. Among them, of course, the climate change and energetic issues. Our students, this new generation, is fully aware that we face critical planetary boundaries involving climate change, biodiversity loss, pollution, ocean acidification, and they want to act. Among the hundreds of PhD subjects chosen every year and built by our students at ENS, 2/3 are related to issues tackled by IPCC in its large spectrum. Understand the physical science basis, mitigate the climate change, and prepare human adaptation and prevent vulnerability. Their strengths and engagement are an incredible source of hope, despite the very worrying context. As their teachers, we feel in high responsibility to help them and to raise high and strong the values of environmental transition and sustainable development. To finish this introduction, I think that we share another concern, the fact that research needs to be shared and understood as largely as possible in order to enlighten the deciders and the general public. In the current context of climate change and global energy crisis, it's vital to place research and education in the center of solutions search. The Technical Support Unit works at the unique IPCC interface between science and policy. We are therefore very proud and fully committed to help by hosting the Technical Support Unit of the Group 1 of IPCC here at ENS. You have such an important work to do. So I will stop here and leave the floor, but again, thank you so much for visiting us here and for sharing your presentation of the conclusions of the 6th IPCC cycle and the first ideas to grow the next 7th cycle.
Thank you, Nathalie. I will give the floor to Sophie Zopa, who is representing the Paris-Saclay University. Sophie, the floor is yours.
Merci Robert. Bonjour à toutes et tous. Donc, bienvenue à Sir Jim Skea, président du groupe d'experts intergouvernemental sur l'évolution du climat, ou GIEC en français. Je me permets de reprendre la parole en français, mais Jim m'a dit qu'il comprenait le français, donc je pense qu'il n'y a pas de souci et que ce sera plus simple pour beaucoup plus de monde ici. Donc, bienvenue à l'Université Paris-Saclay. Donc, ce séminaire vise à relier les connaissances qui ont été évaluées dans le cadre du 6e rapport avec la vision qui peut exister pour le 7e rapport du GIEC. Et nous sommes ravis de l'accueillir dans notre université qui, à travers ses unités de recherche, contribue à la recherche sur le changement climatique depuis plus de 60 ans. Donc, au cours de ces dernières décennies, la recherche scientifique a permis de caractériser de nombreux problèmes environnementaux, leurs causes, et également d'évaluer les solutions pour les atténuer. Et ces connaissances ont servi à informer les décideurs politiques sur des questions qui vont, par exemple, de l'altération de la couche d'ozone stratosphérique qui a été évaluée grâce au rapport de l'Organisation mondiale de la météo sur l'évaluation de l'ozone, le changement climatique dont l'évaluation des connaissances est faite par le GIEC, ou la perte de biodiversité qui est évaluée dans les rapports de l'IPBES. Et de nombreux chercheurs de l'Université Paris-Saclay ont participé et continuent de participer activement à ces évaluations. Des chercheurs comme Jean Jouzel ou Jean-Charles Ourcade ont été impliqués dans ces évaluations de connaissances pour le GIEC dès le 2e rapport du GIEC qui est sorti dans les années 90. Et cette implication s'est en fait accrue de rapport en rapport, notamment au travers l'évaluation des connaissances pour les groupes 1 qui évaluent les bases sur la physique du climat et le groupe 3 qui évalue les solutions d'atténuation. Et puis, on a également eu de plus en plus d'experts qui ont participé au fonctionnement du GIEC, avec évidemment ces dernières années la coprésidence du groupe 1 par Valérie Masson-Delmotte et aujourd'hui par Robert Votard, qu'évidemment nous remercions. Donc cette expertise, en fait, elle reflète un engagement collectif beaucoup plus large dans la production des connaissances, dans toutes les dimensions en fait du changement climatique. Donc, en particulier, les chercheurs des différents labos de recherche de Paris-Saclay analysent de très nombreux indicateurs qui sont extraits d'un très large éventail d'archives qui permet de reconstruire les climats du passé, de comprendre l'évolution de la circulation océanique, le cycle de l'eau, la végétation et différents paramètres physiques dont on peut reconstruire l'évolution. On a également au sein de l'Université Paris-Saclay des mesures en continu et parfois depuis plusieurs décennies de la composition en gaz à effet de serre, mais aussi en gaz réactif et en aérosol. Et puis, on développe aussi à l'Université Paris-Saclay des instruments satellitaires qui permettent de mieux comprendre les échanges d'énergie, de matière et d'eau entre les surfaces continentales et l'atmosphère. Donc, les chercheurs de notre université ont, au travers de ces travaux, participé à une meilleure compréhension du cycle du carbone et de son évolution sur différentes échelles de temps. Et ce cycle du carbone a pu être mis en œuvre dans les modèles du système Terre, aux côtés plus récemment du cycle de l'azote ou de la dynamique de la végétation. Également, au sein de l'Université Paris-Saclay, l'étude des SLCF, les Short-Lived Climate Forcers, qui ont ma préférence, je ne vous expliquerai pas aujourd'hui pourquoi, mais qui sont en fait des composés réactifs qui agissent sur la pollution et sur le climat. Mais on étudie aussi au sein de nos laboratoires de recherche plus largement les interactions entre chimie atmosphérique et climat. Et tout cela a contribué à faire évoluer le modèle du système Terre de l'IPSL, qui est un des 2 modèles de système Terre français. Tout ça est aussi rendu possible parce qu'on a une expertise sur l'ingénierie du calcul haute performance qui est absolument indispensable pour faire tourner ce genre de modèle. Donc ces modèles, ils sont appliqués à de très diverses échelles de temps, depuis des passés très lointains jusqu'aux projections futures. Et puis, on développe aussi des modèles qu'on appelle de complexité intermédiaire au sein de l'Université Paris-Saclay. On participe également à la modélisation climatique régionale, qui est indispensable pour mieux anticiper les effets du changement climatique et l'adaptation. Et puis, on développe aussi ce qu'on appelle des modèles inverses qui permettent de mieux caractériser les sources de gaz à effet de serre. On a également des équipes qui travaillent sur l'impact du changement climatique sur l'agriculture et sur les écosystèmes. L'université contribue également au développement de scénarios socio-économiques et de trajectoires d'émissions de gaz à effet de serre par le biais du développement d'un IAM, un Integrated Assessment Model, et puis aussi au travers d'émulateurs. Donc, comme nous le savons tous, on a besoin que des solutions soient déployées massivement et très rapidement pour limiter les pertes de biodiversité et le changement climatique et réduire les impacts de ceux-ci. Et on a également à l'université des efforts de recherche importants sur les solutions qui restent essentielles, même si le GIEC permet d'évaluer des solutions déjà existantes. Et on a des chercheurs qui travaillent actuellement sur des solutions qui sont aussi bien technologiques que basées sur la nature, réglementaires ou politiques. Donc, la recherche qui est faite dans les unités de Paris-Saclay permet de contribuer à relever ces défis et en particulier de regarder comment est-ce qu'on peut produire de l'énergie, de l'alimentation, des matériaux de manière durable, comment on peut repenser les villes et les territoires ou les infrastructures de transport dans ce contexte de très forts changements environnementaux. Et puis, la transformation rapide de nos sociétés est également un sujet de recherche majeur pour les chercheurs de Paris-Saclay. On a aussi bien de la recherche juridique en écologie qui permet par exemple de questionner comment le développement de nouvelles technologies peut remettre en cause la préservation de l'environnement, la liberté et la justice. On a également des réflexions sur la manière d'intégrer la valeur du patrimoine dans les enjeux de durabilité environnementale, ou des chercheurs qui s'intéressent aux effets socioculturels induits par les changements environnementaux et par les transitions sur des sociétés particulières, et en particulier pour les sociétés arctiques. On s'intéresse également aux inégalités de santé et aux hétérogénéités d'accès aux soins. Et puis, on a des recherches sur l'économie, la gestion du développement, l'équité inter- et intragénérationnelle dans le cadre de ces changements, et beaucoup de réflexions sur l'analyse des politiques qui sont menées et sur leur efficacité. Le partage des connaissances et la coopération sont indispensables évidemment pour mener la transition, et donc l'université a évidemment une stratégie importante de sciences ouvertes et de coopération avec les pays du Sud qui est fondamentale dans ce contexte. Et depuis 2020, l'université forme également l'ensemble de ses étudiants de licence aux enjeux d'érosion de biodiversité et de climat. Et les récents rapports de la R6 ou les rapports qui vont sortir de l'IPBES d'ici à la fin de l'année vont permettre justement de remettre à jour ces connaissances, en tout cas la manière dont on les enseigne, ce qui est évidemment indispensable à la vitesse à laquelle ces connaissances évoluent. Et puis, on a également une formation qui est en train d'être montée pour l'ensemble des personnels de Paris-Saclay pour leur permettre de comprendre quelles sont les conclusions de ces grands rapports scientifiques et de s'approprier aussi à la fois les solutions, mais aussi les barrières qui peuvent exister au déploiement de ces solutions, et permettre de comprendre comment est-ce qu'on peut se placer sur des voies de développement durable. Donc, dans ce contexte, nous sommes absolument ravis, évidemment, d'accueillir au sein de l'Université Paris-Saclay l'unité de support technique du groupe 1 et le coprésident du groupe de travail du groupe 1 du GIEC, donc cette fois au sein de l'ENS, même si nous avions déjà accueilli Valérie dans le cadre de la R6. Et puis, on voit aujourd'hui que ça nous permet aussi de saisir des opportunités, d'avoir parmi nous des conférenciers extrêmement inspirants, comme aujourd'hui Jim Skea, président donc du GIEC pour la R7. Je vous remercie.
Merci beaucoup, Sophie. Jim, I will call our speaker, Jim Skea, but just a few words. So Jim, you were elected in July 2023 as chair of IPCC. IPCC is GIEC en français, is IPCC in English. I'm working with you, Jim, since then, because I'm a co-chair of Working Group 1. You have done many things. I will not enumerate all of them, but maybe a few ones. From 29 to 2023, you were a professor of sustainable energy at Imperial College in London, with research interests in energy, climate change, and technical innovation. You were research director of UK Energy Research Centre in 2004 to 2012, and the director of the Policy Studies Institute before then. So you have been always operating at the interface between research and policy, and also technologies, especially renewable energy technologies. So we are really happy to have you today, and I'm going to give you the floor now. Thank you.
Okay. Merci Robert, Sophie et Nathalie. Désolé, je vais parler en anglais. C'est mieux pour moi, c'est mieux pour vous. Okay. Okay. So what I will be talking about is precisely what the title of the talk says. I know not everybody is familiar, are climate experts, and may not be familiar with IPCC or GIEC. So I will spend a few slides talking about that. Then I will talk about the key findings from the last cycle of IPCC, which were approved about 15 months ago. And then I'll talk a bit about the future work, which is something that Robert is also extremely interested in at the moment, because he and his colleagues will have to deliver it while I claim the glory. So there we go. So in terms of what IPCC is, it was established in 1988, a long time ago, and it has now gone through 6 cycles of activities. It was set up through an agreement between the UN Environment Programme and the World Meteorological Organization. And the objectives I've got on the screen to assess on a comprehensive, objective, open and transparent basis information relevant to understanding climate change, its potential impacts and options for adaptation and mitigation. So not just the physical science, but the actions that can be taken in response to the scientific findings. The interface with policy is very important. There is a very strong statement that IPCC reports should be neutral with respect to policy, but they may need to deal objectively with scientific, technical, and socioeconomic factors relevant to climate action. In other words, we don't make recommendations about what governments might do, but we can make a statement such, if you take this action, then these are the consequences that would follow, and approach that in a very scientific way. IPCC has a very complex governance structure. I am now in my 3rd consecutive cycle of IPCC, and I am not sure I still understand how it works, but let me do my best. Now, one very important point is that the I in IPCC and in GIEC stands for intergovernmental. And I think we forget this at our peril within IPCC, because governments will take ownership of IPCC at the end of the day. We have 195 member states at the moment. There is only 1 member of the UN missing. And the governments meet together usually twice a year in a full plenary to either approve the scientific outputs or to conduct their business. The plenary, the governments elect a scientific leadership for IPCC, known as the Bureau. That includes the chair, the vice chairs, and the co-chairs of the individual working groups, like Robert. And a smaller subset of that Bureau forms the executive committee, which again, Robert and myself are both members of, which can take urgent decisions between meetings of the overall panel. Right from the beginning, IPCC established 3 different working groups for its activities, each with 2 co-chairs and a bureau consisting of working group vice chairs. Working Group 1 on the physical science, which has now been hosted for 2 consecutive cycles here. First Robert in this cycle, but Valérie Masson-Delmat in the previous cycle. Working Group 2 on impacts, adaptation and vulnerability. Working Group 3 on mitigation, which basically means reducing emissions or increasingly enhancing sinks of taking carbon dioxide out of the atmosphere. And then the forgotten part of IPCC, the Task Force on National Greenhouse Gas Inventories, which produces recommendations for governments on how they report their emissions and sinks to the UN Framework Convention on Climate Change. It's invisible, it's very technical, but it is very important. And I can assure it's technical because I spent 3 days in Vienna this week at their expert meeting on carbon dioxide removal and carbon capture and storage, and they do go into a lot of depth. So that's the basic overall structure. But let's not forget the hundreds upon hundreds of scientists, including Sophie, who have been involved in producing the reports, because once we get going, the governments may nominate authors to take part in the authoring of the reports. And from that large number of nominations, the Bureau selects those who will be on the list. And typically in past cycles, governments nominate about 5 or 6 times as many people as there are places for in actually writing the reports. So the selection is a very difficult and sometimes fraught process. For recent activities, the ratio has been near, we had 13 times as many for a scoping meeting on climate change in cities. So IPCC is really attracting attention among scientific communities. We have a huge challenge at the moment because the work IPCC does not conduct its own research. It assesses science that is out there already. And at the moment, the volume of scientific literature is doubling every 7 years, roughly every IPCC cycle. So in the last year, for example, this is slightly below, but my estimate was that about 55,000 pieces of work were published relevant to climate change, which means that cumulatively there are now about 500,000 pieces of literature out there since IPCC started. And this is a big challenge for us in the future, is how scientists assessing that volume of work can extract themes and make the key findings evident for policymakers. This is just to represent the fact that IPCC has also become very important in the policy world since it started back in 1988. IPCC's first report preceded the signing of the UN Climate Convention in 1992 and had a big influence on that. Our third assessment report fed into the Kyoto Protocol when it was signed in 1997. And more recently, the fifth assessment cycle was absolutely critical for the signing of the Paris Agreement in 2015. So I'll be coming on to this, but there's been a huge amount of interaction between IPCC as an institution and the UN Framework Convention on Climate Change. And for example, in the last cycle, it was that under the Paris Agreement, IPCC was very specifically invited by the governments to produce a special report on global warming of 1.5 degrees, which is the one that Valérie, led on the production of in the last cycle, and has that rather striking cover image in the front that we can all remember. I always think of it as a combination between an IPCC figure and an early Pink Floyd album, but that's another comment. Just to emphasize the fact that, IPCC has been valued by the policymaking system. So turning on to the second part of the talk, and I aim to leave plenty of time for questions because I find them much more interesting than listening to my own voice, quite frankly. So the last IPCC synthesis report was approved by governments about 15 months ago, and it was structured in a very simple kind of way. It had 3 topics within it. The first one was current status and trends. Where are we now with climate change and climate change action? Second section, looking at long-term climate and development futures, thinking out over the 21st century. And the third part was near-term responses in a changing climate. What could policymakers do immediately to address the challenges of climate change? So that's the way the synthesis report was structured, and I'll run through each of these sections quite briefly. So current status and trends. There's quite a lot that can be depressing in this section, because there has not been nearly as much action on climate change, I think, as anyone would like. So going back to the start of the industrial period, which is conventionally taken as 1850, when records are available, greenhouse gas emissions have continued to rise by about a couple of % per year over that entire period. There have been short periods where emissions have fallen, but nevertheless, emissions still appear to be on an upward trend. And what this is breaking it down, it's looking at which greenhouse gas emissions matter. So about 2/3 of it coming from carbon dioxide originating from fossil fuels and industry, the most important part. Net emissions of carbon dioxide from land use change and forestry, and then greenhouse gases other than carbon dioxide. And there I would specifically mention methane, which has quite a short life in the atmosphere, and nitrous oxides being the 2 most important other gases. But everything has been rising over this period. Now, one thing that was introduced in the scientific literature and assessed by IPCC was the concept of the carbon budget. Carbon dioxide emissions stay in the atmosphere once emitted for a very long time. And it was possible in the 5th cycle to produce a figure which showed that global warming was related in an almost, but not exactly, linear way to the cumulative amount of carbon dioxide that was put into the atmosphere. And that, of course, leads to the conclusion that if you want to stop global warming, you need to bring carbon dioxide emissions to net zero, a phrase that has become very widely accepted. It's also the case that if you want to limit warming to any particular level, you can identify a carbon budget, which is a limit on the amount of carbon dioxide that can cumulatively put into the atmosphere if that limit is to be adhered to. And what this figure from the synthesis report has done is to compare at the top. I don't think I've got a pointer. Oops, that was not intended. I was trying to get to the pointer there and did not succeed. What it was to compare in the top bar the historical emissions since the start of the industrial period, and compare it with the remaining carbon budgets for warming of 1.5 degrees, 2 degrees with a high probability, and 2 degrees with about a 2/3 probability. Now, just to say, one of the problems with IPCC, we do move slowly. We can only, we have cut-off dates for our literature, and the carbon budgets numbers there are reliable on literature that was published up till about 2022, I think, in the case of Working Group 3. So, in fact, there has been subsequent scientific analysis that shows that the carbon budget for 1.5 degrees isn't 500 gigatons, as shown on this diagram. It's probably half that level, given that we have continued to emit carbon dioxide at roughly the same level. In this diagram, we then compare it with the level of carbon dioxide emissions that would take place, assuming we had constant emissions during the 2020s. It's roughly the same as the 1.5 degree carbon budget, as was assessed in the synthesis report, which might be lower now. And it's also compared at the bottom with lifetime emissions from fossil fuel infrastructure, both existing infrastructure, which exceeds the 1.5 degree budget, or existing and planned infrastructure, which almost exhausts the budget for 2 degrees. So again, this is quite a depressing picture, and it has led to statements about the likelihood that we will surpass or reach global warming of 1.5 degrees within the next decade. The strong conclusion, the NDCs stands for Nationally Determined Contributions, which are the pledges that governments make under the Paris Agreement to reduce their emissions. And what we've done in this diagram, which goes up to the end of the century, is to compare what would happen depending on what governments actually do with where you would need to be if you were going to limit warming to given levels. So the pink band at the top shows the trend from implemented policies in place at the moment, which shows basically the implemented policies will probably lead to a slight increase in emissions. The purple band below that, going up to 2030, is where governments would take us if they implemented all of their nationally determined contributions. And thereafter, it follows a path compatible with 2 degrees. And then the striking fact is that the blue band at the bottom shows where you would need to be if you had started from 2020. And that's an important qualification. If you were to limit warming to 1.5 degrees. And the magic number we came up with was a 43% reduction by 2030 if you were going to be on a 1.5 path. And just to flag, again, because the world has changed since these reports were published, that 43% number is not one that I think that would be reproduced if you were to do the work again. The green band just below it shows where you would need to be if you were to limit warming to 2 degrees. So a very clear picture from this. There is a so-called emissions gap. There is a big gap between what countries have promised to do under their nationally determined commitments and where you would need to be to limit warming to 1.5 or 2 degrees. But importantly, there is also an implementation gap, which is the difference between what governments have pledged to do and what they're actually doing on the ground in terms of policies. So both the emissions gap and the implementation gap would need to be addressed if we were to put ourselves onto 1.5 or even 2 degree pathways. Another very big conclusion that came out that got a lot of attention, especially from least developed countries, was the question of equity and the distribution of emissions around different countries. And in the report, we looked at that from two perspectives. We looked at historic emissions, given that CO2 emissions accumulate, historic emissions back to the start of the industrial period, but also a snapshot of current emissions and compared it across different regions of the world. So on the left-hand side, that's showing cumulative CO2 emissions since the pre-industrial period. On a quick summary, between North America and Europe, these account for about 40% of total cumulative emissions of carbon dioxide. Won't go through it all in detail, but if you move to the right-hand side, you can see, for example, that Southern Asia, Africa, much smaller proportion, especially if you focus only on the blue component, which is emissions from fossil fuels, as opposed to emissions related to land use change. So big differences and inequalities in terms of historic emissions. On the right-hand side, it's a snapshot of greenhouse gas emissions per head in 2019. And again, it shows the same picture. North America, nearly 20 tons of carbon dioxide per capita. Southern Asia down to about 2, and Africa down to about 3 tons per capita. So very big differences. And this debate about equity and responsibility for emissions is a big part of political discussions, as well as something we've had to grapple with in IPCC. So something we did in the synthesis report was to try to bring together the impacts and adaptation worlds in Working Group 2 and the mitigation world in Working Group 3 by plotting on a symbol diagram an an indication of the vulnerability of populations to climate change on the vertical axis and emissions per capita on the right-hand axis. And it's a very clear message that comes out of it. Those who have contributed least to climate change are the most vulnerable. And these are messages that are coming over very strongly in the debates within the UNFCCC. And my apologies, I have a tickle in my throat and I need to consume some water to keep myself going. Now, that's all been really bad news, and we try not to depress people too much. We need to keep some messages of hope in there. So let me tell you the good news stories in terms of current trends as well. The progress that renewable electricity has made has been remarkable over the last decade. So both photovoltaic, solar, and batteries for electric vehicles have fallen in cost by about 80% over the last 10 years or so. And this is remarkable progress that has resulted in renewable energy now accounting for about 10% of electricity generation globally. And this was unimaginable, I think, 10 or 15 years ago. The bands at the top are based on cost, and you can see a yellow band there, which shows the cost of generating electricity from fossil fuel, with obvious uncertainties in different parts of the world, and showing a very clear message that renewable energy is cost competitive with fossil fuels for electricity in many parts of the world now. And the bottom figure just shows the rate of adoption since the year 2000, which again is quite extraordinary in terms of the growth rates, about 50% per year for solar energy, for example, about 20% for wind energy. And before I leave that one, I might also say that the question of policy development is also a sign of optimism. About 90% of the world's economy is now covered by net zero emission targets. Now, we don't have the policies in place to allow these net zero targets to be met, but there's a clear statement about the aspiration of major world countries. 50% of global emissions are covered by formal policies and institutions, and about 20% of global emissions are covered by some kind of carbon pricing, whether it's permits or taxation. So we have all the tools in place, and what we need to move on to is the question about whether these tools are actually going to be taken up. So turning to the second part of the synthesis report on long-term climate and development futures. There were some conclusions, which is kind of at the bridge between the Working Group 1, Physical Science, and the Working Group 3, Mitigation world, showing that pathways that limit warming to 1.5 degrees all reach net zero carbon dioxide emissions around the middle of the century. Now, carbon dioxide emissions are not the same as greenhouse gas emissions, and greenhouse gas emissions net zero would come rather later. So the left-hand side is showing that carbon dioxide in the middle of the 21st century, greenhouse gas emissions in 1.5 scenarios later in the century, around the 2080s, 2090s to get there. The right-hand side shows what pathways you would need to be on to limit warming to 2 degrees, and that moves out to about 2060 for carbon dioxide. And indeed, in many of the scenarios for 2 degrees, greenhouse gas emissions never reach net zero during the 21st century. If they get to net zero at all, it would be into the 22nd century. One thing about this, now that net zero has got such a big currency, I used to say in the UK, we have a government department with net zero in its title, so it's truly been absorbed in the system. Reaching net zero does not necessarily mean that it's going to happen at the same time in each sector and in each country. And this is really important to pick up. So this is pulling apart the 1.5 degrees compatible scenarios where total emissions would get to net zero about 2050. The first sector to get to net zero then is actually land use change and forestry, which under these scenarios gets to net zero about 2030. Second sector to go net zero would be energy supply, especially electricity, where we'd be reaching net zero about 2040. And in what you might call the energy demand sectors, transport, industry, buildings, in fact, carbon dioxide never gets to net zero because some activities simply cannot be substituted. You simply cannot get there. And non-CO2 emissions are another one which never reach zero. There is no credible way of removing emissions other than carbon dioxide from the atmosphere. So an important point, when we talk about net zero in 2050, if we're talking about energy supply or land use, we need to actually move more quickly in these sectors than you would do in terms of the average picture. This is where I get onto shakier ground scientifically. This is the work of Working Group 2, which looks at impacts and adaptation under different scenarios. And what, as a kind of bridge between the Working Group 1 and Working Group 2 worlds, the concept of a global warming level has typically been used to form the scientific bridge. So for a given level of global warming, which is on the vertical axis, you would assess the kind of risks that are being faced by different systems. And basically the intensity of the color suggests the level of the risk. And you may think this is casual and aesthetic, but believe me, the Pantone number is calculated very carefully, scientifically, to ensure that this is traceable back to the underlying literature. I won't explain the whole range, but where you have white level, there is basically no detectable risk. Where you get to the very strong purple level, you're talking about severe risks that have an irreversible character to them, and that's the nature of the range. So one thing to flag up is that in the report of the 6th cycle, the risks were now assessed to occur at lower global warming levels than they previously were in the 5th cycle. So not only is the world warming up more quickly than we thought, for any given level of warming, the risks associated with that have actually increased according to the scientific assessments. This also goes into the different kind of systems that face the risk. On the left-hand side, we've got land-based systems. On the right-hand side, ocean and coastal ecosystems. And I think the key point there to pick out is to look at the kind of transitions that take place between 1.5 and 2 degrees warming. And for many systems, the risks are actually rising very significantly as you move from 1.5 to 2 degrees, which is the reason that the Paris Agreement was constructed in the way that it is. So I think the risks in general, probably more severe on the land-based side. So we've got increased levels of wildfire damage, permafrost degradation, biodiversity loss, especially where the risks are accelerating between the 1.5 and 2 degree levels. The risks accelerate generally in ocean ecosystems at higher warming levels. But one to just flag out the left-hand one under ocean and coastal ecosystems, where warm water corals have proved particularly vulnerable to climate change. And even at 1.5 degrees warming, you could see coral reefs in tropical waters declining by 70 to 90%. But if we go to 2 degrees warming, we lose them, almost all of them, entirely. It's one particular vulnerable system. Something that is not covered there is sea level rise in general. And obviously for human systems, the question of sea level rise and resilience to that is a subject of real challenge. And just to say, there is a big flywheel effect in the global system. Even if we stopped emitting now, sea level would continue to rise and people would face higher risks. So turning to the final section on near-term responses in a changing climate. And I think the big message is here that there is an awful lot that we can move forward on in terms of addressing climate change. So there's a little saying that I am inclined to use, is that a good figure can save you 1,000 words, but an IPCC figure takes 1,000 words to explain. So I will approach these figures with just a little bit of caution. This is an example of one of them. In the synthesis report, there was an attempt across working groups 2 on adaptation, working group 3 in mitigation, to take particular systems and address what the kind of response, how effective responses were for adaptation, which is the left-hand side, and on the right-hand side, look at the potential for reducing emissions. Because this is such a complex diagram, let me focus in on it more specifically and explain one particular element of it. So this is about mitigation in the energy sector and for agriculture, forestry, and other land use. So what this is showing is the potential by the year 2030 to reduce emissions at different cost levels. So red color, the most red color means it's going to cost you more than $100 per ton of carbon dioxide equivalent to reduce emissions. The yellow one shows it's less than 20 tons US dollars per ton. And the blue one shows that you would actually save money by doing the measures anyway. They're basically negative cost in terms of emissions. So this has clearly identified a very large portion of global emissions that could be reduced in the short term at pretty cost effectively at the moment. And in the energy sector, the two that jump out are solar and wind energy, which follows from the conclusions that I had mentioned already. But there was another big potential for reducing methane emissions from coal, oil, and gas systems, which frankly can be done at really quite low cost. And there are many oil and gas companies that could actually make money out of reducing their methane emissions because they could sell the methane emissions to consumers and make money out of it rather than just leaking it into the atmosphere. And quite frankly, they have not looked for these opportunities in the past. Now that they've been alerted, there's a lot more work going on. In the short term, options like bioelectricity, nuclear energy, fossil fuel carbon capture and storage are much lower potential in the near term, but they might have more potential as you go beyond 2030. Also, huge potential contributions in the land sector. So reduced conversion of natural ecosystems, carbon sequestration in agriculture, ecosystem restoration, for example, restoring forests and peatlands, are all things that that could help us there in the near term. And just to give you a sense of the scale, the solar energy at the top, we're running up to almost 5 gigatons of carbon dioxide per year reduction potential, which is about 10% of global greenhouse gas emissions. So you're getting a sense of the size of the opportunity that stays there in the short term. It's all available on the line for anybody who's taking pictures. Now, one other thing that we did, which was a novelty for an IPCC mitigation report essentially, was to pay much more attention not to the technological aspects of reducing emissions, but the social and the behavioral aspects. We had a whole chapter on consumption and behavior issues in Working Group 3 in the last cycle, which was a genuine innovation. So what our colleagues who were working on that chapter did was to look at the demand side reduction potential by 2050, simply from consumption and behavioral related issues. And they came to the conclusion that depending on the end use sector that you looked at, that these emission reductions over the middle of the century were between 40 and 70%. And the structure they used was to think about what human needs are. So they started thinking about needs for nutrition, needs for mobility, and needs for shelter, and how these needs could be delivered in ways that would involve lower emissions of greenhouse gases. And that's where they got the 40 to 70% number, looking through the literature. They also identified the means by which these emission reductions could be achieved. Was it socio-cultural factors? In other words, the kind of choices that people could make. Was it a question about the kind of infrastructure that was available? Or was it about the kind of technologies that people had the option of choosing? I think there was quite a strong conclusion. There was a tendency to say it's all up to people and we should switch the light off. Actually, the conclusion was that these individual measures only had a certain degree of contribution. Unless you were backed up by the availability of infrastructure, the availability of technology, these behavioral choices could not be exercised. So quite an important message there for policymakers as well. Individuals are important, but it's far from being all down to individuals. I would flag just on the left-hand side, the one which looks at nutrition. And there is a big blue box on social cultural factors. And this got to one of the more sensitive topics we raised in the last cycle, including in the special report on land use, which is the question of dietary choices and greenhouse gas emissions. About a third of global emissions are associated in some way with the global food system, and a lot could be achieved through dietary choices or by limiting food waste, which tends to be people in developed countries leaving food on the side of their plate, or in developing countries, the losses tend to take place before the food actually gets to the plate. It's losses in the distribution system. But that was a big new message for Working Group 3. I will also mention that because the net zero concept has come there, and there are some sectors where you can never eliminate emissions, you can only get to net zero if you can take carbon dioxide from the atmosphere. And I think another big advance in the last cycle has been to think more systematically about the potential for carbon dioxide removal. And the very interesting thing is that there is no carbon dioxide removal technology. There are lots and lots of different methods and approaches which vary in terms of the mechanism from taking carbon dioxide from the atmosphere. Is it chemical or is it biological? Where the carbon dioxide ends up, is it in biomass, or is it in products like timber used for houses, or is it in geological formations? And it varies according to the durability with which the carbon dioxide will stay in these stores. So for the first time in the last cycle, I think we pulled that apart in a lot more detail. And the meeting I've just come from in Vienna was actually an expert meeting conducted by the Task Force on Inventories, which is to think about how governments could report these carbon dioxide removal techniques under the UN Framework Convention on Climate Change. And believe me, they got into technical detail on these things. At the moment, in terms of carbon dioxide removal, most of it is happening through reforestation or avoided deforestation. But there are many other techniques at a much lower level of deployment now, including enhanced weathering of rocks, burying biological slurries underground, all sorts of things under consideration at the moment, which currently have a very low level of deployment. And the last point I want to make, and my joke about 1,000 words to explain a diagram equally applies to this one, which is the importance of linking climate action to wider action on sustainable development and the Sustainable Development Goals. And what this type of diagram does is to try to map each of the Sustainable Development Goals against a set of climate actions. Now, to cut through all of this, basically, it's looking for synergies, and the blue represents synergies, and the origins, the orange parts of it represent trade-offs or things pulling in the wrong direction. So big message, the potential synergies much dominate the picture here. There are many potential synergies between climate action and pursuing other sustainable development goals. And a classic example would be, for example, the deployment of electric vehicles, which reduces air pollution in cities with benefits in terms of health effects. That's a classic example. It is important to look out for the trade-offs, and some of the biggest ones identified in the last cycle were the large-scale deployment of bioenergy and potential consequences for biodiversity and food system resilience. So there are these issues that need to be addressed. And the final point on this one, I'm sorry, it's not a very visible diagram. And the reason it's not very visible is that governments couldn't agree to put it into the Working Group 3 final summary for policymakers last time, but it's there in the technical summary and is available for use. And the third goal of the Paris Agreement is making sure that there are sufficient financial flows to deliver mitigation across developing countries and also adaptation. We don't have very good data on adaptation, but one thing people in our investment and finance chapter did in Working Group 3 was to compare current financial flows for mitigation with those that would be required to limit warming to 1.5 or 2 degrees. And the headline figure was that you would need to scale up current investment flows by a factor of 3 to 6 if you were to put us onto 1.5 or 2 degree pathways. The gap is actually lowest for energy supply and renewable energy because for obvious reasons it's becoming cost effective. The gaps are much bigger for energy efficiency and transport systems. And in relative terms, they're absolutely largest for land use type of measures where the money is really not flowing in the ways that it need to. And there are far bigger gaps in developing countries than there are in developed countries. So a very strong set of conclusions about that, about the need to scale up financing. Now, one thing to say there, this covered mitigation. A conclusion on adaptation is that the gaps are even larger, though they weren't quantified in this kind of way. And one of the reasons that all adaptation is being paid for by government funding rather than private sector financing, this includes private sector finance flows, and there more than 90% of the investment in adaptation is taking place from public sector funding. And it is a big challenge for the next cycle of IPCC to pay more attention to financing issues in relation to adaptation. Now, I've given myself, because I had a target, I've given myself 0 time to complete the third part of the talk. But I think it will probably go much more quickly, which is to think about where IPCC is going to go in the future in terms of its priorities. And we are still working out exactly what our program of work will look like in the next cycle. But one thing I do want to flag, at the end of 2023, the first global stocktake of progress under the Paris Agreement took place. And one of the specific outcomes was to invite IPCC to consider how to align its work with the second and subsequent global stocktakes. Next one, 2028, the one after that, 2033. So really inviting IPCC to provide relevant and timely information for that important political process. Now, we had a meeting in Istanbul, the first full plenary meeting of the 7th cycle earlier this year. And true to the invitation, the IPCC did consider how best to align its work, but it was the consideration that was the key word, because I'm not quite sure that we reached a conclusion on the alignment quite yet. So it was a very intense meeting. In classic IPCC style, we were supposed to finish at 6 o'clock on Friday evening. We actually finished at 10 o'clock on Saturday morning, having worked without halt during the night. And in spite of that great effort, we came up with a remarkably conservative set of conclusions. So in the next cycle, we will be producing the 3 working group reports again. And the governments want them to take place in the sequence 1, 2, and 3, physical science, impacts and adaptation, and mitigation, unless they make a different decision in the future. And it also the governments could not agree on a timeline for producing these reports and requested the Bureau, the elected scientific leadership, to prepare a document outlining the year and month of delivery. Now, Robert knows all too well the challenge of getting the Bureau to agree on something to put forward there, but there will be a document that goes to the next plenary session, which starts in Sofia in Bulgaria later this month. It confirmed that there is going to be a special report on climate change in cities. The scoping meeting has taken place, and when we get to Sofia at the end of the next month, one of the jobs of the governments is going to be to agree the outline of that special report on climate change in cities. And the task force and inventories will provide a report on short-lived climate forcers. Item 7 has been delivered as of about 6 o'clock yesterday afternoon. The Task Force on Inventories has held an expert meeting on carbon dioxide removal technologies, carbon capture, utilization and storage. And the Bureau was also invited to consider options for expert meetings and workshops. So just two final points on what we do have planned for the next cycle. Many years ago in 1994, IPCC produced some technical guidelines on impacts and adaptation. And when I looked at them again, I discovered to my dismay that I was one of the experts that helped produce it. And I have no memory whatsoever of doing it, which is quite embarrassing. So that's for IPCC's institutional memory. But we will be producing new technical guidelines on impacts and adaptation. And one of the things the governments want is much more evidence on adaptation indicators, metrics, and methodologies. We have metrics for mitigation, its carbon dioxide equivalent. For adaptation, many, many more different indicators might be needed. And governments do need a lot of help in thinking their way through that. And that will be produced alongside the Working Group 2 report on impacts, adaptation, and vulnerability. And the final one, we will be producing a synthesis report for the 7th cycle, and the governments could agree that that would be produced by late 2029. That is actually my responsibility. I heard there were 2 or 3 governments said they wanted to do away with a synthesis report, which would have made my life very easy because I could spend the next 6 or 7 years making speeches, going to dinners and basking in the glory of the efforts created by my working group co-chair colleagues like Robert and others. But I think we will continue with the synthesis report. And so just to say, I mean, IPCC is a consensus-based organization. We cannot come, pulling 195 governments together and getting them to agree is not an easy task. So this kind of symbolizes the process. This is the dignified UN part of that. I think that's actually the UN headquarters in Nairobi. That's what a plenary session of IPCC looks like in the top right-hand side. The bottom left shows the less formal aspect as we're all scrambling to get agreement in the final moments of the meeting. And then at the end of it, you have the joy of bringing down that gavel when all the work is done. So I hope to be doing lots of gaveling over the next few years and perhaps less of the bit in the bottom left-hand side. But I'll stop there and thank you very much for your attention.
Thank you, Jim. Thank you so much. And we will have time for questions now. Looking at some questions in the middle. So yes, on this side. So who is, yes. Yes, thank you, Eloise. And then,
Wait a bit. Okay, thanks. Thanks for your talk. So let me be a little bit pessimistic and expect a rise of temperature rather higher than 1.5 or 2 degrees. So I've understood that there are, mitigation or adaptation measures that are possible. Many reasonable models, I've heard also, predict quite different scenarios in terms of changes, their intensity or maybe even nature sometimes depending on the part of the world. So I've heard that for each scenario, there are some effective measures that we can think of. But my question is, are there measures that would be very efficient for some scenarios and counterproductive for some others? And the second part of the question is, are there measures that actually would be robust, would be effective or even efficient, regardless of the reasonable scenario we expect? And I'm asking this as a researcher because I want to foresee how I could orient my research in the long run without knowing specifically which scenario will unfold in the future. So thanks.
Yeah, worthwhile saying that models and scenarios are not about predicting. They are about future possible states of the world. So let's just say, I think in Working Group 1 world, prediction is more realistic. In the Working Group 3 world, we're talking about so many socioeconomic uncertainties, we can only hypothesize about the future. But on the scenarios, I think there are a lot of measures out there, and the reason for these slides on the near-term responses is that these are things that you would want to do regardless of what the climate outcome is. All of these are robust, and you would want to take them forward. So I think that's about. Then there's an awful lot out there. We can do so much with existing technologies and potential practices. I think where it gets more problematic is where you get measures that might interact with other sustainable development goals. I've mentioned bioenergy and interaction with food security and biodiversity. And in the Working Group 2 world, there's also a lot of topic about so-called maladaptation, where you put in place adaptation measures that make sense in the short term, but actually may put you in a worse place in the long term. So, for example, protecting property with seawalls will only work up to a certain level. If we're going to see very high levels of warming, it may turn out that that has encouraged people to settle in places where that would not have been a good idea. So I think you've got to look at it case by case. But whatever you're doing, whatever the projected warming level is going to be, the thing is, more climate action always makes sense. Every fraction of a degree does make a difference. And at the moment, the avoided impacts of climate change, the value of these greatly exceeds the mitigation costs on the current trajectory we're on at the moment.
Here. Thank you very much for this talk. This is very useful as a teacher or professor at the university to be able to be reminded the key messages that we can use to build up new courses for our students. I have a question regarding mitigation, still keeping on the mitigation aspect. One of the figures show that the different sectors, including food, industry, but also a limitation of action. Once you've changed behaviors, and I was wondering whether it's possible to find or to identify why we cannot go below that. And I was noticed that it was particularly high on the industry level, for instance, and I would be curious to know why can't we go below that? Is it related to the economic model, or is it related to why can't we do anything? We are the one in charge of all those things, so why can't we go below?
Right. Oh, okay. I mean, you can't answer that term generically. You need to go into each individual sector. But most industrial energy use is coming from big commodity materials like steel, cement, and chemicals. And there are genuine limitations about what you can do there just because of the physics and chemistry of the processes. And it may be in some of these sectors, the only thing you can do is carbon capture and storage, for example, because the carbon dioxide emissions are sort of unavoidable. When you produce cement, you inevitably not just from burning the fossil fuels, but the chemistry of the process also gives rise to carbon dioxide emissions. So industry is a classic example of what is called a hard to tackle sector. It's really difficult. And because the companies in it are exposed to international competition, they have very high costs of capital, which makes it difficult to invest. So that's a trouble. In other areas like buildings, for example, you can also take a life cycle approach and look at the carbon content of the materials that are embedded in building houses, and you just think about what is required there in terms of the materials to build a new house. It's very difficult to actually change that. And the food system, the food system, is somewhere else. This is a particularly difficult and culturally sensitive sector to deal with. So I don't think there's a generic answer to your question. You need to go into a bit of depth in each sector.
Thank you very much for your presentation. So you say that the work of IPCC is a work of consensus. So my question is, are there some conclusions that are now consensual that were not consensual in previous iterations of IPCC reports because of governments not being able of finding a consensus?
Right. Well, for example, a big conclusion of the sixth cycle is that human beings are unequivocally the cause of the climate change that we are observing. That was not a conclusion that could have been reached in the early cycles of IPCC. And it's partly because the science did not quite support it. So when the governments were pushing the scientists hard, that kind of conclusion would not be possible. And in fact, if you look at about the political sort of sensitivity of IPCC, the most politically sensitive parts during its evolution were probably in the early days when the existential question was, are human beings causing climate change? That was basically the question. That issue has now been resolved with the unequivocal statement, but now we're in another, perhaps more politically difficult phase because we're looking at climate action. And that once again has brought issues like the scenarios we produce into sharp focus, how ambitious they are. So I think all of us think that IPCC is much more caught in the political crosshairs now than it was perhaps in the middle part of its life. It was certainly caught in the political crosshairs earlier on.
Okay, thank you. Thank you for your talk. It was really interesting. I have a question. So regarding, if we look today at the projection that we would need to the reduction of greenhouse gases that we would need to do just to get to our 2 degrees limit or so on. The thing is that I think I don't want to be too pessimistic, but I think that we are on target to get to maybe 3 or 4 degrees, if not more, given the current situation. But I mean, sorry to be pessimistic. But the thing is that, and I will go more into the work of the mitigation project, like, do we have like a good plan of do we have an idea on how, if we are, like, what's the certainty of we can tackle an issue, climate that rise to 3 or 4 degrees, and we will still be able to, as much as we can, mitigate the effects? Like, do we have any plans for that?
Yeah, I mean, the scenarios that IPCC assesses, and there's a process outside IPCC with a coupled model intercomparison project, and they show they take into account a wide range of emission scenarios, and the higher end of that range would be, at the kind of levels that you're talking about, 3.5. So the scenarios are actually in there. Now, one thing that's worthwhile saying is that the Working Group 3 reports tend to focus on what is ambitious in a mitigation sense. So you tend to see more attention being focused on 1.5, 2 degree scenarios. In Working Group 2 on impacts and adaptation, which I might say has historically paid a little less attention to scenarios, they've tended to focus on the higher end of the warming spectrum. In particular, they focused on one particular scenario, and sorry for the jargon, RCP 8.5, representative concentration pathways of 8.5 watts per square meter, which is now considered to be quite an implausible scenario in terms of emissions, because if you were to get these outcomes, you would have to assume that the world dismantles all the wind turbines and solar panels. It's just not a credible scenario in emission terms. My own view is that it would be, I think it does make sense, if you want to put in a precautionary adaptation policy, that you do need to look at these higher warming levels. I mean, I think people would need to be, if they're being precautionary, they need to think the world could warm at these kind of 3 degrees. It's not what we want, but it might be what we need to live with. And so, one of my predecessors as IPCC chair, it was in the old days, he said, aspire to 2 and plan for 4. That was basically the message.
Thanks for coming and explaining all of this to us. You noted that the number of papers just doubles every 7 years. And I would like to speak about disinformation. Do you have a mission to fight it? Do you measure it? Is it going as fast, doubling every 7 years? And how can we help against disinformation?
Yeah, we don't track, I don't think we track misinformation very, very systematically, because we certainly don't want to include it in our reports. But certainly in the Working Group 3 report, where there are that we have chapters on policies and institutions, we have discussed the way in which public debates are actually formed in relation to climate change. We have absolutely, I could not produce you a figure with the same growth in misinformation that we have for the actual published papers, but it's been noted in a qualitative way in some of our reports.
Hi, I have a question. Thank you for the talk. It's a similar question to that and to the consensus question, because the IPCC is a report that summarizes the current state of the science. And so you have a lot of the scientists kind of side of where scientists think things currently are versus this document that's also meant to be for policymakers. And you have, as you mentioned, governments or the UNFCCC who has certain things that they may want to see in the document. So I'm just curious, when you're constructing it, how you reconcile maybe where scientists might be pushing in one direction and either scientific or political sensibilities, or the governments might be pushing in another direction. How do you reconcile those?
Yeah, I mean, these two things are happening at the same time. And I wouldn't say that science works entirely, it does not work in a vacuum at the moment. I mean, scientists are as conscious of it as anybody else, I think, of the world in which they're operating. And in many types of scientific career related to climate change, IPCC and the climate debate actually establishes the direction that the scientific inquiry actually takes. And I would say this was especially important in the Working Group 1 world in physical science, and also in the scenarios world that some of the Working Group 2 and 3 people have been involved in. So they're not entirely independent worlds from each other. And my particular regret is in relation to the social sciences and humanities, where we struggle to get people as involved as they might be, because their career development and structures is not so tied up with the climate world. So naturally, they're perhaps more reluctant to get involved. But I mean, I mean, I've been working at that bridge between science and policy forever now, the national level as well as internationally. The interface you're talking about is the one that absolutely fascinates me, and it's the one I get my kicks from. So there.
Yes, thank you for your excellent talk. I saw that your mandate is part of your mandate is also to look at the CDR processes, because you mentioned them, but there are other processes that are looked out now about in order to reduce temperature, like solar radiation management. I was wondering whether in your mandate you will have to evaluate these possibilities, which are receive a lot of funding now.
Yeah. Solar radiation modification is a tricky subject for IPCC because it doesn't fall within the remit of any one working group. It's not a mitigation strategy because it's coming back afterwards. It's more remediation than mitigation. We do cover it in the report. So Working Group 1 in the last report did look at the physical science aspects, what kind of changes to the Earth system interventions would make. Working Group 2 looked at the consequences of deploying some of the techniques in terms of wider environmental impacts. And Working Group 3 was charged with looking at the legal social and ethical aspects of solar radiation modification. And it was all joined together in a single cross-working group box, which tried to summarize it. So we do cover SRM, but governments did not want to see that in the summary for policymakers and taken up to the top level. There have been suggestions by some people that we should produce a report on solar radiation modification, but governments find this a really tricky one to deal with. At the last UN Environment Assembly in Nairobi, there were draft resolutions on SRM, which simply didn't make it for political reasons. So we're covering it, but it's not getting the same attention as CDR, that's for sure.
Do you mind, Jim, if I just add one point on SRM? If you look at the expertise that we have called for in the nomination for experts for the scoping meeting, if I remember well, SRM is mentioned because it's a topic that we probably cannot avoid, despite the difficulties of where to put them. So we don't know exactly yet how it will be framed in AR7. That's our experts who will also say that in the end of the year. But certainly it's not something that is forgotten.
You mentioned the fact that sociological and behavioral data was more and more important and taken into consideration. And you just mentioned as well that including social science and humanities was a difficulty. So I was wondering, in the evolution from, I would say, hard sciences towards taking into account social sciences and humanities, are you changing the way you are working? Does it have an impact on to take into account new interdisciplinarity aspects?
This I think, honestly, is work in progress. It was very interesting when we put together that new chapter on behavior and consumption. My hope would been that we'd got lots of people who had done been social scientists all the way from Anthropology 101. What actually we got was that about half the chapter consisted of engineers and physicists who'd had a change of heart in the middle of their careers and had suddenly discovered social sciences, which was a very, very interesting kind of outcome. I mean, the way I would put it is that IPCC likes social scientists more than social scientists like IPCC. And I would like to get them more engaged. I think there are more social scientists studying IPCC than there are participating in it at the moment. If we're honest, my ambition would be to get more. I think the reason that it partially worked with that chapter is that we put a flag in the ground with the title of the chapter and said social scientists welcome. And I think that's where you start to get social. So if you have a chapter called policies and institutions, if you have a chapter on you'll get the political scientists, the international relations people coming. If you have a chapter on behavior and consumption, you'll get sociologists, psychologists, etc. Finance and investment, we'll get economists. I think you need to think very carefully about how you scope a report to make it look attractive to social scientists. And of course, the other issue we haven't got, of course, the different social sciences have alternative framings for how the world works. And that's a particular the challenge for social scientists to work with each other is also there as well.
I'm involved in a movement called Extinction Rebellion that is stronger in England than in France. We are making civil disobedience. Thousands of scientists have seen paper to make civil disobedience. Would you personally think that it's working, that we succeed to pressure government at least a little by this solution? Here we were at the campus sometimes Valérie Basson-Delmotte. She took position against the dissolution of Les Soulèvements de la Terre. That was a political strong conflict in France. What's your position without that? Would you promote a civil disobedience? Would you maybe yourself do civil disobedience?
Action. the effectiveness.
Yeah, in terms of the effectiveness of civil society action, I mean, the answer is that we don't know at the moment how effective it is. If I think of the Just Stop Oil groups that have been working in the UK, they've probably had a positive impact in that they have kept climate action in people's minds, but they have probably alienated lots of other people as well, and partly provoked some of the the reaction against climate action that we've seen. So I think in the future, I have no doubt that social scientists will be working on papers on the effectiveness of civil society action. And when they produce these papers, we stand ready to assess them. But I don't think we've got the literature in place at the moment to understand scientifically whether that action is effective or not.
It's a relatively new scientific topic, actually.
My question will be about the social science aspect and also the behavioral aspect, and also kind of about the raising of awareness aspect. My question is, do we know, well, does the IPCC work on how effective or how important is the issue of, for example, teaching or general information of the public of people on these subjects?
Just as when Valerie Masson-Delmotte was co-chair of Working Group 1, she paid an enormous amount of attention to to the question of communicating knowledge about climate change to wider bodies. Now, I'm not going to be negative about this, but one thing that we got pushback on from some governments was that in reinterpreting material and putting it out in a simple form, it took away from the carefully negotiated, approved languages that government came to in plenaries. So my preference would be, it is important. I mean, we know the reports can be incomprehensible to lay audiences. That's well understood. I think in reinterpreting them and putting them out, it's best if it's done by third parties who can take responsibility for interpreting it for particular audiences. And IPCC authors can advise them and do everything like that, but at the end of the day, somebody else takes responsibility. And there's a very good example of that from the last cycle, where there were summaries for urban policymakers produced by groups outside IPCC, but we gave them a lot of help in the process, and they actually were quite successful in focusing IPCC messages.
Yeah. We can take one or two more questions, and
I think the previous gentleman didn't get a satisfactory answer.
Yeah.
Yeah, sorry, probably I didn't ask my question the way I should have asked it, because my question is, as you mentioned, for example, that the financial aspect is really important in order to get some changes of emissions, etc. Does IPCC studies the impact of teaching and information on the opportunity to reduce emissions? Because, for example, when you're an engineer, if you have been taught about these subjects, then you would probably be more careful about about the energy consumption and the CO2 emission, etc. But if you have never been really exposed to this information, then you just won't care.
Right. Within the scope of that new chapter, for example, on behavior and consumption we had, well within its scope was any evidence on the evaluation of interventions to try to change behavior and consumption patterns. I would have liked more of that evaluation, what works kind of material in that chapter. And there's actually a conference took place in Berlin about a month ago, which was essentially about the what works agenda and how you can assess that. So personally, I think it's important. The problem is that many of these studies and understandings are not in the scientific literature. They're done by consultancies for governments or agencies like ADEME in France, and they're much more difficult to access. And we need to think about that. I think the co-chairs in Working Group 2 and 3 are now much more interested in making a bigger effort to broaden the evidence base that IPCC assesses so that we can address the kind of issues that you've just mentioned there. But it's not easy.
We will take one question from each side of the room, but no more because we need to conclude. Yeah, please.
Thank you. I just have a simple question about one of the figures presented. It's about the cost effectiveness of each energy, solar, nuclear, etc. I was wondering if the externalities of each energies were considered in the cost effectiveness.
The short answer is no, and this was the subject of great internal debate within the chapter as to whether they should be included. There is a clear statement in the footnotes that the externalities are not included.
Hi, thank you for the talk. I wanted to ask if you have ever hesitated in putting positive news in the IPCC report, as you feel it would deserve the cause, being instrumentalized by policymakers to overshadow the real issues on the report.
Can you repeat because, yeah.
Yeah, have you ever hesitated in putting positive news in the IPCC reports, as you feel it would deserve the cause, being instrumentalized by policymakers to overshadow the real issues present in the report?
Yeah, it's a communication on positive.
Yeah. One of the things that we have been conscious of the fact is that continuous kind of messages about the risks of climate change, which are obviously real and very important and substantial, can sometimes inhibit action rather than actually promoting it. And we constantly try to get over the message, no matter where you are, there is a really, really strong case for climate change action. And so that people are not disempowered, and I think that's a risk of constantly emphasizing the problems that we're facing. We have tried to make sure that we are presenting to people that there are real options out there for taking action to climate change that are available if policymakers choose to actually exercise the options. So it is a bit of a conscious choice that I'm particularly concerned about, that we have to have a balance. Sorry, this is a little bit tacky, but when we were at COP28, we were attending to use the acronym UAE to describe our messaging. And the UAE stood for urgency, which was the level of the risks, agency, because we had the tools to do something about it, and equity, because unless you had a sense of fairness, society as a whole would not get behind climate change action. So I think all of these factors are really important.
The very last question from the bottom here, and then we have to stop. I'm sorry about that.
Hi, thank you for sharing your work with us. My question would be around whether is the IPCC involved into any degrowth or post-growth scenario for societies who are trying to adapt to new context and parameters, ways to live, ways to survive, ways to thrive, etc.
Yeah, I believe the word is actually mentioned in some of our chapters, but it obviously depends on getting a literature for us to assess that actually goes through it. I mean, just to say, I get very nervous thinking about degrowth. As somebody who's chaired a Just Transition Commission nationally, I think about how, okay, degrowth would be a good outcome, but what does it involve to actually get there in terms of youth unemployment, social dislocation, etc.? That would be what I would really like to see.
Okay.
Just a short comment. What if we don't have the choice? What if degrowth arrives by itself and we cannot control it?
If somebody produces scenarios by which it is put upon us, yeah, obviously, publish literature on it and we will assess it.
Yeah, need to be. So I would like to thank you all and thank our speaker, Jim, for being with us. Jim will be also with us this afternoon, but we also have to discuss about IPCC processes and so on. So thank you again.